Okay, right now we're going to talk about multiplying fractions, and before we do, we should mention a couple terms. Those terms being numerator and denominator. The numerator being the top number in a fraction, and the denominator being the bottom number in a fraction, the denominator down. That's how I remember them. What parts are they? Why are they important? Well, they're important because they describe what's going on with a fraction. If we consider this square to the right to be our whole, we can see that it's cut into 3 parts. Well, that's the denominator's job. It tells you how many parts the whole is cut into. So if it's cut into 3 parts, then we're talking about thirds. And the numerator tells us how many parts of the whole we're referring to. So if I said what portion of that square is shaded in, we could say 1 out of the 3, or 1/3 of the whole is shaded. Okay, so the denominator tells us how many parts, and the numerator tells us how many parts we're referring to, how many parts we're talking about. So another quick illustration of a fraction. Again, the square is the whole, and we'll be shading 3 parts out of the 4, and our fraction is 3/4. Okay, so if we're using, and as we're talking about fractions and multiplying fractions, if we're using the square to represent a whole, then if we want to look at a whole number, we can look at the single square, and how many parts is that single square cut into? 1. And how many parts of it are we referring to when we talk about the one whole? 1 out of 1. So the fraction 1/1 represents the whole number 1. So its value is 1. So let's say we want to talk about 3 wholes. So remember, each square represents 1 whole. So how many parts are the whole cut into? So if we're going to say that this models the number 3, and we say how many parts are the whole cut into, not the group, but the wholes, each one is cut into 1 part. And then if we said, well, we're referring to all 3 wholes, then we're talking about 3. So as a fraction, a whole number is written as that number itself over 1. So 1 as a whole number is 1/1. 3 as a whole number would be 3/1. 10 as a fraction would be 10/1. And so what do you think these other ones down the bottom here, 8, 12, and 32, would be as fractions? Again, whole numbers written as fractions are that number over 1. Whole number as a fraction are that number over 1. So if we're talking about 8, 12, or 32, then we're talking about the whole number 8 would be 8/1. The whole number 12 would be 12/1. The whole number 32 would be 32/1. Those are our fractions, our whole numbers written as fractions. And it's important when we start looking at multiplying. First, we're going to look at multiplying fractions times whole numbers. Okay? So keep that in mind. Whole numbers as a fraction are that number over 1. And the numerator and denominator, the job they do. Numerator, or the denominator, how many parts are the whole cut into? And denominator, how many parts are we referring to? Okay, so here we have 4 wholes. Okay, so this, again, we look at the squares themselves. This represents the number 4, which is important, because what I want to do is I want to take 2/3 of the 4. Okay, we're going to see as we're talking about are keywords in their operations. The word of refers to multiplication. So if you ever see a fraction of a number, we're talking about that fraction times that number. So of means multiply. So if we're taking 2/3 of 4, well, if you look, each of my four, my wholes, are cut into thirds. So if I take 2/3 of each of the 4, okay, we have how many shaded in now? We have 1, 2, 3, 4, 5, 6, 7, 8. And what are they? They're thirds. So we have 8/3. So what we just said is 2/3 times 4 equals 8/3. Well, don't forget what we talked about up top. We talked about any whole number written as a fraction is that whole number over 1. So 2/3 times 4 is 8/3. So when we're talking about multiplying fractions, look at, what do you notice when we look across here and here? And we're talking about multiplying. If you look closely, we have 2 times 4 is 8, and 3 times 1 is 3. If you saw that, or if you see that now, then you've just realized that multiplying fractions is pretty easy. It's pretty basic, because when you multiply fractions, it's the numerator times the numerator over the denominator times the denominator. And unlike adding and subtracting fractions, there's no like denominator to find. It's just straightforward numerator times numerator over denominator times denominator. Okay, so let's consider 2 more examples. Let's say we talked about 7/9 of 6. Okay, well, again, a whole number as a fraction is that whole number over 1. And multiplying fractions, as we saw right above, is just numerator times numerator. 7 times 4, 42. In fact, let's do it this way, just for illustration. Numerator times numerator over denominator times denominator. So 7 times 6 is 42. 9 times 1 is 9. All right, one more example. Let's talk about 8/11 times, so we'll say 8/11 of 5. Okay, remember, whole number over 1. So 8/11 of 5 is 8 times 5, 40, over 11 times 1, 11. Okay, now we're going to see something this year, and as long as it's in simplest form, as long as our fractions are simplified, then we're not concerned about, for now, we're not going to be concerned about mixed to improper and improper to mixed. We can leave it improper. But if I use my rules of divisibility, I go back to this one here. I see that 42 and 9, they're both divisible by 3. And 42 divided by 3 is 14, and 9 divided by 3 is 3. So we can leave it improper, but we want to make sure it's simplified. And 40 over 11, we can leave as 40/11, or if you really like to make improper fractions to mixed numbers because you don't like how they look, then we can change 11 into 40 goes 3 times with a remainder of 7/11. Okay, so as long as our fractions are in simplest form, we're happy. We can leave them improper or improper if we want, and we'll see why as we move along with multiplying and dividing fractions, why sometimes it's better just to leave them improper. All right, now what about if we took 2 fractions? What if we talked about this model here. All right, since we're working with 2/3 already, what if I shaded 2/3 of this in? All right, so that's 2/3 of the whole, or 2/3 of 1, and anything times 1 is itself. So 2/3 times 1, or 2/3 of times 1/1 is equal to 2/3. Well, then we're going to talk about the 2/3. So that's this area here. That's our 2/3. What if I want to take 3/4 of that 2/3? What if I wanted 3/4 of 2/3? We could do that, couldn't we? Sure we could. If we look vertically, our whole is cut into fourths. Okay? So if we took, find a different color, and we took 3/4 of this. So we shade 3/4 of the whole. And look at the overlap here. This is the area we're concerned with because this is the 3/4 of the 2/3. Well, if we look at the total whole again and look at how it's broken up, right? And we see that our whole is broken up into 12 equal parts. So our whole is broken into 12ths. The part that overlaps the 2/3 of the 3/4 of the 2/3, well, that's 6 of those 12ths, which is equal to 1/2. So 3/4 of 2/3 equals 1/2. And if we look back at our multiplying of fractions here, the 3/4 times the 2/3, we see that 3 times 2, oops, wrong pen. We see that 3 times 2 is 6, and 4 times 3 is 12. And then we can simplify that down to 1/2. So again, that just repeats what I mentioned earlier, is that when we're multiplying fractions, it's numerator times numerator over denominator times denominator. Numerator of the first fraction times the numerator of the second fraction over denominator of the first fraction times the denominator of the second fraction. So let's do one more example, and then I'm going to give you 4 to try on your own, and we will cover the rest again in class. But again, keep in mind, this right here is how we multiply fractions. Okay, that's the key to it all. Okay, so let's say we had 7/9 times 2/5. Okay, so 7/9 times 2/5, or 7/9 of 2/5. Well, it's numerator times numerator. 7 times 2 over denominator times denominator. 9 times 5. So it's 14/45. And that's how you multiply fractions. It doesn't get any easier than multiplying fractions. Numerator times numerator, 7 times 2 is 14, over denominator times denominator. 9 times 5 is 45. Okay? So, quick review. The numerator, how many parts are we talking about? The denominator, how many parts is the whole broken into? Whole numbers as a fraction, 8. Is that whole number over 1? So if we took a fraction of a whole number and we treated the whole number as a fraction, so 2/3 times 4, numerator times numerator, 2 times 4, 8. Denominator times denominator, 3 times 1, 3. Okay. numerator times numerator over denominator times denominator. Again, leave improper fractions improper, that's fine for now. Just simplify. Simplify always mixed. Yeah. For now, when you want. We're going to see when using an improper fraction is better than a mixed number anyways. Okay, so one last review. Numerator times numerator or denominator times denominator. So a fraction of a fraction. 7 times 2. Oh, wrong pen again. 7 times 2, 14. 9 times 5, 45. Numerator times numerator over denominator times denominator. Here's 4 more examples for you to try. Alright, so you can pause this video now. Do those 4 for me. Have them for class tomorrow. And you'll be all set.